Howdy, 7th grade. Today we're looking at how to find the area of a trapezoid, or as they say in Europe, a trapezium. I don't know why they call it a trapezium, they just do. But if you're curious what a trapezoid is, it is a four-sided shape where two of the lines are parallel. So anytime you got four sides and two lines are parallel, it is a trapezoid. And we're going to look today at how to find the area of such a thing. So in the past, what we would do with a trapezoid, we would break it up into sections that we can deal with, because we know how to find a rectangle here, and we know how to find the triangle here, and the triangle here. But it's not always going to be maybe that easy. So what we're going to do today is find actually a simpler way than breaking it up into all these parts, so that we don't have to worry about breaking these parts apart every time we have to find an area of this shape. So I'm going to show you guys a couple of different ways to think about this, and we're going to use the same example for our trapezoid every single time. So for my trapezoid example, we're going to have a shape that has a height of 5. This bottom part is going to be split into 3 because we have these triangles here. So this middle portion is going to be 10, which means the top is 10. And on the outsides, we are going to have a 4 over here and an 8 over here. So what that means is the total bottom right here is going to be 4 plus 10 plus 8, which is 22. It's 5 tall, and that top is 10. So let's start by doing this the old way. If I want to break this apart into a few different sections, I have my left triangle, have my right triangle, and I have this rectangle in the middle. Now my rectangle is 5 by 10, this triangle is 4 and 5, and this one is 8 and 5. So by breaking it up, I could find the area pretty quickly. The area of this triangle right here, 4 and 5 are the sides, so our formula for a triangle is 1/2 base times height. 4 times 5 is 20, divided by 2 is 10, so that's the area. For this rectangle right here, 5 times 10 is 50, and here I have 5 times 8 is 40 divided by 2. 40 divided by 2 is 20. So I can add all these up and find that the area of my trapezoid is going to end up being 80. So 80 is the answer, and if we get 80, then we know we are on the right track. But breaking this shape up is kind of weird and complicated and not too much fun. So I want us to think about this a different way. So I'm going to take my trapezoid, and what I want to think about doing is we are going to take this, and we're going to take this top line, and we're going to shove it that way. Move it over here. And the weird thing is this doesn't actually change the area of our trapezoid, because as we move it, the length across here stays the same, so the amount of area it takes up is actually identical. So if we move it, what we end up with would be a shape that has still the 10 here, 12 over here, and 5 tall. So I'm just moving it so I have 2 right angles, and what I'm left with now is 1 triangle, which is a little bit easier. I'll give you that. So if we start with this, I have this right here, 10 by 5 has an area of 50, 5 by 12 is 60, divided by 2 because it's a triangle, 30 and 50 plus 30 is going to be 80. And that makes me happy because that's the right answer. But I think we can do better. We made it so we only had to split it once, which is great, but we can do better. So let's try something a little bit different. We moved it, so we have this right here as our trapezoid. And this line isn't necessarily there, but I'm going to draw it in as a dashed line just so we can kind of see where that triangle starts and stops. And what I want us to do now is think about taking this triangle and cutting it right in half and swinging this point around this way. So what that would end up looking like would be, I cut my triangle off. That was an awful drawing. Let me try that again. I still have my rectangle here, but now I have my triangle, which I cut off, and the other part, which will end up fitting right on top. A nifty thing about how ratios work is if I do this halfway over here, so that these two sides are the same, this will be halfway up of that, so when I flip it, we'll end up with a nice little square. So what happens then is that now the length of my bottom of my rectangle is going to be the 10 plus half of what my triangle was. So my triangle was 12, now it's going to be 6. And it's still going to be 5 high, so I end up with 16 times 5, which is 80, which I think is a lot nicer than having to break it all up. So if I do this every time, what ends up happening is that the length of my rectangle is going to be the length of the shorter side. So I started off with a trapezoid that was 10 on top, 22 on bottom, and 5 tall. So what's going to happen is I'm going to have the length of my rectangle, which is going to be the length of the shorter parallel side. And in this case, that's going to be 10. So I have 10, and then I'm going to add to my 10 for my rectangle right here what this 6 was. And what that 6 is 1/2 of my triangle length. And if we think of what the triangle length was, it was what was left over after we took this rectangle out of the bottom side. So what that means, we're going to take our bottom side of 22, subtract the 10, and so I have 10 plus 1/2 of the difference there, and that's going to be the bottom. And then I can multiply by the height, now that I've made a nice little rectangle. Multiply that by 5, and we should be all good to go. Going through here, I have 10 plus 1/2 of 6. That shouldn't be 6, 1/2 of 12. I already did the 1/2. Getting ahead of myself. 1/2 of 12 times 5, which is 16 times 5, which is 80, which makes us happy. So how I could write this, if I wanted to, let's label our trapezoid real quick so we can know how to work with it. This right here, I'm going to call base 1 and base 2. And base 2 is bigger than base 1, so that makes our lives a little easier, and the 5 is just going to be the height. So we have two different bases, which are parallel, right here and right here. One's longer than the other. And I also have a height. So how I'm going to write this is now base 1, which was my 10, plus 1/2 base 2 minus base 1 times the height. And man, this looks ugly. Thankfully, we can simplify this a little bit. I won't get too much into the algebra, but what ends up happening is we get base 1 plus base 2 divided by 2 times the height. And when we see this, what I want to think is average. So what we're doing is we're taking our two different bases, we're adding them together and dividing by 2. So we're finding the average base length. So the average length, if we have our trapezoid here, the average length would be right about in here, and our height's there. So if we find the area enclosed in that, it would be the same thing as the area of our trapezoid, which kind of makes sense. So just kind of to make sure you remember, the most important part of this video is what I'm about to write. Area equals base 1 plus base 2 divided by 2, which is going to be, again, our average base length times the height. So our area is going to be base 1 plus base 2 divided by 2 times the height of our trapezoid. So I want to try this formula out on maybe 1 or 2 examples, and we'll be all good to go. So my first example is going to be a trapezoid that looks like this with an, sorry, that should be a 12, 12, 8, and 24. That's not how you write 24. 24. So what I'm going to do is I'm going to average the 8 and the 24. And when I do that, what I get is 8 plus 24 divided by 2 times the height, which is 12. 8 plus 24 is going to be 32. 32 over 2 is 16. So my final answer will be 16 times 12. Let's see, 16 times 10 is 160. 16 times 2 is 32. 160 plus 132 is 192, which would be my final answer. So you can use this formula with any trapezoid you see. And one more time, I'm going to make you guys write it twice. Plus base 1 over 2 times the height. This right here is our fancy formula for the area of a trapezoid. Use it all the time. Make sure you do the lesson practice, and I will see y'all in class tomorrow. Toodaloo.